I just hit the record button and go for it, right? Okay, so 2.7 ready and go. Review. A lot of review, stuff we haven't seen in a while. So I can't expect you to remember much, but we're just going to see what you do. It says all of these equations are linear equations. I'm not concerned with the first one because we haven't really talked about, and you probably never saw that form much, even in your other class. Number 2, even, although this is standard form. In number 2, I would use 0. That should be a T, not an F. I'd use 0 to find X and Y intercepts. Okay, so that's how I would graph that. And if you remember, if you look at a graph, my Y-intercept would be here, my X-intercept would be here, and that's how I'd graph the line. Right, so you use 0, plug 0 in for X, solve for Y, plug 0 in for Y, solve for X. Right, again, not going to harp a lot on that. Why? Because the last one here is the form you should be familiar with. And the form that you should be familiar with, when we look at this, what are the numbers? H of X, or Y, is equal to negative 4X plus 9. What's the negative 4? Anyone? Come on, that's going to be my slope. Right? So my slope is negative 4. And what's the 9 going to be then? Y equals mx plus b. Been a while since you've seen it then. Okay, I identified m, b is 9. My y-intercept is 0 and 9. Not 9, 0 and 9, because every point on a graph has a x and y value. Next we look at 3 different exponential functions. It says, I know I covered it up, it says exponential functions. Okay? So if we look at this in the form, this form that it's in, and we did this a lot in Module 1, but it's been a while, since we talked about that. What is 5? How can I label 5? Anybody remember? First term. 5 would be the first term. So if I look at a table, okay, the first output value would be 5. What's the 2? Common ratio. So if I want to find other output values, what do I do with the first term? I multiply it by the common ratio. So the next output would be 10 and 20 and 40 and so on. That's kind of how you do that, right? I've got some students in my Math 1 class, because it's real heavy on exponential functions. They're sitting there doing 4 different equations to find output values instead of doing one equation and then using your common ratio to find the others. So they're doing more work, and that's something that we got to work on. Number 5, what is the notation W times X minus 1? Do we remember what that notation means? Again, it's just notation. That means previous term. Or f of x minus 1, that's how we saw it most of the time, f of x minus 1. What are we doing with the previous term? No, look at the equation. What are we doing? Previous term, what? Multiplying by what? 4. So if we're multiplying by 4, there's my common ratio. Okay? So times 4, times 4, times 4, times 4. Because remember, in exponential functions, they have common ratios. They don't have common differences. Linear functions have common differences. And then what about W of 1 equals 13? What does that mean?
First term.
First term. Very good. Okay? Again, it's just notation. So we're revisiting that. Number 6. Can we figure out number 6 based on 4? What is 2? What's that?
Common ratio?
No. First term. Okay? The common ratio in this case is 3. So again, if I look at a table, first term is 2, How would I get to the second term? Times it by 3, so 6. The third term, times it by 3, 18, and so on and so on and so on. All right? Use your common ratio. And that's one of the things I'm trying to teach my Math 1 students. Work smarter, not harder. You don't need to do a bunch of different equations. And I get it, it's tough. All right, now we move on to the, oops. Sorry, that was the ready. I missed the retrieval, darn it. Oh well. That's okay. I need to go back, sorry. Because this is one of the 5 I want to do today. Graph the parabola, include the vertex and 2 accurate points on each side of the axis of symmetry. So what form do you see in the problem? We have 3. We have vertex form, standard form, and factored form. I know it's hard to see those on camera, but if you're in class, you have those 3 forms. Which form do they give me? They give me vertex form, okay? So in vertex form, I should be able to identify the vertex. If I can identify the vertex out of that form, I should know an A value, an H value, and a K value. And I should also know the line of symmetry. It seems like a lot. Gee, that's 1, 2, 3, 4, 5 things you want me to know, Mr. Wilson. Oh, no, it's not 5, it's 6, because I'm going to include the y-intercept as well. That's a lot of stuff. It seems like a lot, it's not. Right? And we'll walk through it. That's the whole premise of reviewing this stuff. We've seen this before, but again, it's been some time because we spent time on standard form and converting to vertex and standard form and factoring. And we spent a lot of time doing all that stuff. Okay? Can anybody tell me what the vertex is by looking at this form right here? We gotta remember, and I know it's tough. What's A? Let's identify A.
2.
2. What is H? Be careful, be careful. You had it right the first time. Remember, the general form is always x minus. This is x minus, which means H is positive 3, not negative 3. Okay? Because remember, when we graph it, remember the Desmos activity we did? My graph is right here. If it's x negative 3, it actually shifts to the right. So it's plus. What's K?
Negative 6.
Negative 6, all right? So now we identified A, H, and K. Of the 3 letters, A, H, and K, which letters make up the vertex? What does A do? Makes it
stretch or shrink.
Stretch or shrink and open up or open down. Can't very well do that. Open up or open down. Okay? So it can't be A. So the other 2 letters that make up your vertex are H and K. So 3 and negative 6. There you go. I've got 4 of the 6 things. It wasn't that difficult, right? Line of symmetry. What's the line of symmetry? The line of symmetry is always x equals. Well, first of all, let's go back and figure out what the line of symmetry is. What does the line of symmetry do? If I have a parabola over here, okay, and I'm going to graph it, where's the line of symmetry?
It's going to be in the middle.
It's going to be in what?
The middle of the parabola.
Very good. Middle of the parabola. Okay? Yes, exactly. So what is that line of symmetry doing to the parabola? He said it's in the middle. Middle means it's dividing it in half. It's cutting it in half, right? Okay? So that's what the line of symmetry does. But what is the line of symmetry? Given all this information, can I determine it? Sure. How quickly we forget. The line of symmetry in this case is x equals 3. Why? Look at what 3 values are connected. The x value of the vertex, the h value, and the line of symmetry. Those 3 values are always the same. They always are. We covered that, okay? And again, it's been a while since you've seen it. Okay? Shaming us for not remembering. Well, gee, it's a lot of stuff to remember. I get it. How about the y-intercept? Well, I'm going to do one of 2 things. I'm either going to find the y-intercept by graphing, or I'm going to find the y-intercept because when I look for a y-intercept, like over here, I did not move right or left, and I moved up or down to find that value. A non-movement is a 0 input. So knowing that, I'm going to plug 0 in for x and solve for y. Or I'm going to try and graph it first, because if I can graph it and just pick the point and write it in there, I've saved myself some time. So let's graph it. I got positive 3, negative 6. 1, 2, 3, 4, 5, 6, right here. So there's my vertex. Now I need to pick some anchor points. I need to pick 3 anchor points on one side, 3 anchor points on the other. Well, how do I pick anchor points? Anchor points depend on my pattern. So my old pattern is what? 1, 4, 9, if we remember that. Okay? That's my old pattern. Okay? But my new one is going to be what? I've got to multiply by 2. I kind of like how I did this in my book. I'm going to multiply everything by 2 to get my new pattern. So my new pattern is going to be what? Again, this is times 2, not minus 2. 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. So my new pattern is 2, 8, and 18. I'm going to move right 1 up 2, right 2 up 8, right 3 up 18 to find some anchor points. So let's find some. So start at the vertex. I'm going to move right 1 and up 2. Normally I'd move up 1, but I'm going to move up 2. I'm going to move right 2 and up 8. So 2, and there's 2, 3, 4, 5, 6, 7, 8. There's a second anchor point. And I got to move right 3 and up 18. I need to move this up just a tick. Well, if I count over 3 and up 18, I end up at, my graph stops at 16. So I can't plot 2 above. I mean, I could put a dot up there, but again, I'm going to stay within my graph. So unfortunately, I can't plot 3 anchor points, I can only plot 2. But that's okay. Because remember, what does your axis of symmetry do? My axis of symmetry, which if you need to draw it, just like I did, draw it, it divides the parabola in half. The first point, gee, if it's 1 unit to the right, I better have 1 unit to the left. The second point, if it was 2 units to the right, I better have 2 units to the left. And there's my anchor points right there. So now I could go ahead and draw my parabola at least somewhat accurately. But remember, I couldn't plot the third points over here. If you notice, if I go back 3 units, that would be on the x-axis, but I couldn't go up high enough to get there. So, I don't know. It looks, the way I drew it, that it would be like 8 or 9, but I don't want to guess. So what I need to do in this case is I need to plug in 0 and solve for x. Remember, 0 is an input, I need to find the output. So this is pretty easy, right? Follow your basic rules. 0 minus 3 squared is minus 3 squared minus 6. Then what do? Then I take care of exponents. Well, this becomes 2 times positive 9, right? Because negative 3 squared is positive 9 minus 6. 2 times 9, because now you follow multiplication left to right in order, it gives you 18 minus 6. And 18 minus 6 is equal to 12. So my y-intercept is 12. Sometimes you might have to input 0. I think on most of the ones you'll have to do here shortly, you can find the y-intercept without doing that. But hey, you never know. All right, so now let's go to the go, and you tell me which of the 4 you want us to do. I'm not doing number 1, because number 1 is the parent function. That's pretty easy. Which one of the other 3 do you think is going to give you the most issues? Survey says probably 30. Because it looks the most complex. Well, yeah, they're progressively getting a little harder. Okay, so let's find the vertex. Sorry for the long video for those of you that are watching this, but hey, we're doing it live. We're live, right? Vertex. What's the vertex? Study the problem and see what the vertex is. Anyone?
1 and 4.
Not 1 and 4.
Negative 1.
Negative 1, very 4. Okay, remember, it's always x minus, so if it's a plus, that 1's actually negative. Identify A, H, K, my line of symmetry, and the y-intercept. Those are the things I wanted us to cover. Right? Well, gee, H and K I should already know. And I should already know the line of symmetry. H is negative 1, K is equal to positive 4, and remember the connection between the x value, the H, and the line of symmetry. Remember that connection? Right here, what was that connection? Those three were always the same. So my line of symmetry is x equals -1. Again, easy. I've got, again, 4 out of the 6 pieces of information. The fifth one is easy. What's my a value?
-1.
-1. Very good. All I had to do was look at the problem, right? Okay? So a is -1, h is -1, kind of a lot of -1s. Now, what about the y-intercept? Well, I do know that the y-intercept always has a 0 x value. I just got to find the y. I could plug 0 in and simplify, just like we did, but maybe I can find the y-intercept by graphing. So let's graph it. -1, +4. 1, 2, 3, 4. My pattern, my normal pattern is 1, 4, 9. What's my new one? Well, what do I have to multiply everything by? I got to multiply everything by -1, right? Because that's my a value. Got to multiply. That's how we establish the pattern, the stretch or shrink. So what's my new pattern? My new pattern is -1, -4, -9. Again, A does stretch or shrink, and A tells me if it opens up or if it opens down. That's what A does. Since this is negative, it's opening down. So I'm going to move what? I'm going to move right 1 or left 1. It doesn't matter. I'll move right and down 1. Right 2, down 4. So 1, 2, 3, 4. And right 3 and down 9. So there's 5, 6, 7, 8, 9. Right there. I was able to have 3 anchor points on the right. Can I get 3 on the left? I should. Now for me, this looks a little off because if I had a line, it would make it a little easier. So if it does, draw that line. It's always dashed. There's your line of symmetry. And again, the first anchor point was 1 to the right, so I better have 1 to the left. The second point was 2 to the right, so I better have 1, 2 to the left. 3 to the right, 3 to the left. And there's your parabola. Do you see the y-intercept? What is it? 0 and zero and 3. You see it from the graph. We can plug it in. Okay? 0 plus 1 is 1. 1 squared is 1. 1 times -1 is -1. -1 plus 4 is +3. So, again, just doing that. Make sure you finish the other 3.